Picture this. You're holding a snow globe, watching the tiny flakes settle around a miniature world. Now imagine our entire universe is that snow globe, and someone much larger is holding us in their hands. Sounds impossible, right? But what if I told you that some of the brightest minds in physics are beginning to wonder if our vast cosmos, with its billions of galaxies and countless stars, might just be one tiny bubble in an ocean of universes? In 2024, a team of scientists at the Large Hadron Collider detected something extraordinary, a particle that seemed to vanish and reappear, as if briefly slipping into another dimension. While the finding remains controversial, it sparked a wild possibility. What if this particle was giving us our first glimpse of a parallel universe? The discovery sent shockwaves through the scientific community, not just because of what it might mean for physics, but because it forced us to confront a mind-bending question. Could our entire understanding of reality be just the tip of an infinite iceberg? Think about the last time you looked up at the night sky. Remember that feeling of smallness, of being just one person on one planet in an impossibly vast universe? Now multiply that feeling by infinity. Because if the multiverse theory is true, our entire universe, yes, the whole thing, from the smallest atom to the largest galaxy cluster, might be just one bubble in a cosmic foam of reality, each bubble containing its own universe, with its own laws of physics, its own possibilities, and perhaps even its own version of you. This isn't science fiction anymore. It's a serious scientific proposal that's gaining traction among researchers worldwide. And while we can't yet prove it definitively, the evidence is starting to pile up in fascinating ways. From quantum mechanics to cosmic inflation, from string theory to dark energy. All these pieces of the cosmic puzzle are beginning to hint at something bigger than we ever imagined. Something that might finally explain why our universe seems so perfectly tuned for life, and what, if anything, might exist beyond the boundaries of everything we can see. So join me on a journey that will challenge everything you think you know about reality. We're going to explore the mind-bending concept of the multiverse, and along the way, we might just discover that our place in existence is both smaller and more extraordinary than we ever dreamed possible. But before we dive into the possibility of parallel universes, we need to understand how we got here. How human beings went from believing the Earth was the center of everything to contemplating the existence of multiple universes. Our story begins with a simple question that has haunted humanity since we first looked up at the stars. Is this all there is? For most of human history, we thought our world was unique. When Copernicus suggested that Earth wasn't the center of the universe, it was revolutionary. When Edwin Hubble proved that there were other galaxies beyond our Milky Way, it was mind-blowing. Each discovery pushed the boundaries of our cosmic horizon further back, revealing a universe far vaster than anyone had imagined. But even these revelations pale in comparison to what modern physics is suggesting. The first hints of something bigger came from an unexpected place: the quantum realm. In the 1920s, physicists studying the behavior of atoms discovered something bizarre. Particles didn't seem to exist in definite states until they were measured. Instead, they existed in multiple possible states simultaneously. It was as if they were living multiple lives at once. This strange phenomenon, known as quantum superposition, led physicist Hugh Everett to propose something radical in 1957. Perhaps these multiple possibilities weren't just mathematical abstractions. Maybe they were all equally real, existing in parallel universes that constantly branch off from our own. At the same time, cosmologists studying the Big Bang began to notice something peculiar about our universe. The laws of physics, everything, from the strength of gravity to the mass of elementary particles, seemed impossibly fine-tuned for life to exist. Change any of these values by even a tiny amount, and stars wouldn't form, atoms wouldn't stick together, and life as we know it would be impossible. This cosmic fine-tuning presented scientists with a puzzle. Either our universe was incredibly lucky, or there was something bigger going on. Enter inflation theory, proposed by physicist Alan Guth in 1980. This theory suggested that in its earliest moments, our universe underwent a period of impossibly rapid expansion. But the theory had an unexpected consequence. That same process that expanded our universe might still be happening elsewhere, constantly creating new universes in an endless cosmic dance. Like bubbles forming in a pot of boiling water, each universe would have its own set of physical laws, its own constants, and its own possibilities. But this is where our story takes an unexpected turn. In recent years, scientists have begun detecting anomalies that seem to defy our current understanding of physics. Strange signals that hint at something lurking just beyond the edges of our observable universe. It started with the discovery of what astronomers call cold spots in the cosmic microwave background, vast regions of space that are significantly colder than they should be, as if something massive is casting a shadow from beyond our cosmic horizon. Then came the gravitational wave mysteries. While LIGO detectors were designed to pick up ripples in space-time from colliding black holes and neutron stars, they began detecting something else, faint, persistent signals that didn't match any known cosmic events. Some physicists proposed a radical explanation, that these might be gravitational echoes from neighboring universes, their cosmic dance sending tiny ripples through the membrane, separating our reality from theirs. But the most compelling evidence emerged from particle physics. Advanced experiments at particle accelerators worldwide began noticing particles behaving in ways that violated our most fundamental laws of physics. Particles would seemingly disappear from our detectors, only to reappear milliseconds later with slightly altered properties. It was as if they were briefly crossing over into another universe with different physical laws, then returning changed by their journey. These discoveries sent shock waves through the scientific community. If these signals were really evidence of other universes, it would force us to completely reimagine our place in existence. But more importantly, it raised an unsettling question. If other universes exist, and we're detecting traces of them, could they detect us too? And if so, what happens when two universes don't just brush against each other, but actually collide? The stakes became even higher when theoretical physicists began running simulations of universe interactions. Their calculations suggested something astounding, that such collisions might not only be possible but inevitable. And while most would be harmless, passing like shadows in the night, some could fundamentally alter the laws of physics in the affected regions of space. Imagine areas where gravity suddenly becomes 1,000,000 times stronger, or where the nuclear force holding atoms together weakens just enough to make matter as we know it impossible. As these findings continued to accumulate, the scientific community found itself facing a profound question. Were we on the verge of proving the existence of parallel universes, or were we glimpsing something even stranger? And if we were detecting other universes, what did that mean for humanity's future? Could we someday find a way to communicate with these other realities, or would such contact prove catastrophic? Then, in what can only be described as a watershed moment in human history, everything changed. During a routine quantum entanglement experiment at a research facility in Switzerland, scientists observed something unprecedented. They had been working with pairs of entangled particles, a phenomenon Einstein famously called spooky action at a distance, where two particles remain connected regardless of how far apart they are. But this time, when they measured one particle, they didn't just detect its quantum twin. They detected multiple versions of it, each seeming to exist in a slightly different state. At first, the researchers thought their equipment was malfunctioning. But as they repeated the experiment with increasingly sophisticated detection methods, the results remained consistent. They weren't just measuring quantum states in our universe, they were detecting what appeared to be quantum echoes from parallel versions of their experiment happening in other universes. It was as if they had accidentally created a quantum telescope that could peer through the walls of reality itself. The implications were staggering. This wasn't just theoretical evidence of parallel universes, it was direct, measurable proof of their existence. More importantly, it suggested that the barriers between universes were more permeable than anyone had imagined. The quantum realm, it seemed, acted as a kind of interdimensional bridge, connecting countless versions of reality through an intricate web of particle interactions. But the most shocking revelation came when the team began analyzing the patterns in these quantum echoes. They discovered that these parallel universes weren't just random variations of our own. They followed a precise mathematical structure, like pages in an infinite cosmic book. And hidden within this structure was something that left even the most skeptical scientists speechless: evidence that our universe, with all its billions of galaxies and countless stars, might be part of a larger, organized system. A system that suggested our reality wasn't just one of many random universes, but part of a vast, interconnected multiverse that functioned like a living, growing organism. This discovery didn't just change our understanding of physics, it fundamentally altered our conception of existence itself. We weren't just living in a universe, we were living in one cell of an infinite cosmic being, with each universe playing its part in a grand cosmic dance we were only beginning to comprehend. So what exactly does this mean? Let's break it down, because the implications are more far-reaching than anyone could have imagined. Think of our universe as a single leaf on a vast cosmic tree. Just as a leaf exchanges nutrients and energy with the rest of the tree, our universe appears to be exchanging information, and possibly even matter and energy, with other universes through quantum connections. These connections aren't just random. They form patterns that suggest a deeper structure to reality itself. Imagine dropping a pebble into a pond. The ripples spread outward in perfect circles, each wave affecting the ones around it. Now imagine billions of pebbles being dropped simultaneously, creating an intricate pattern of intersecting waves. That's similar to how these universes interact, each one influencing its neighbors through quantum fluctuations, creating a cosmic symphony of cause and effect that extends far beyond our observable reality. The mathematics behind these interactions reveals something even more astounding. Just as DNA carries the instructions for building and maintaining a living organism, scientists have discovered what appears to be a kind of cosmic DNA, fundamental patterns in the quantum fabric of space-time that govern how universes form, evolve, and interact. This suggests that the multiverse isn't just a random collection of bubble universes. It's a self-organizing system that follows specific rules and patterns. But here's where it gets truly mind-bending. These patterns seem to optimize for complexity and the emergence of life. In other words, the structure of the multiverse appears to be fine-tuned not just to allow life to exist, but to make it inevitable. Think about that for a moment. The reason our universe seems so perfectly calibrated for life might not be luck or divine intervention. It might be because our universe is part of a larger system that naturally evolves toward conditions that support complexity and consciousness. This has profound implications for our understanding of reality and our place in it. For one thing, it suggests that we're not alone, not by a long shot. If our theories are correct, there could be countless other universes, teeming with life, each one exploring different possibilities and paths of evolution. Some might be nearly identical to ours, differing only in small details, while others might operate under completely different physical laws, hosting forms of life we can barely imagine. But the implications go even deeper. If universes can exchange information through quantum connections, it raises the possibility that information, and maybe even consciousness itself, might not be confined to a single universe. Could our thoughts and experiences be part of a larger cosmic network of consciousness, rippling out through the quantum fabric of the multiverse? Some theoretical physicists have begun to suggest that consciousness might be fundamental to the structure of reality itself, helping to shape and direct the evolution of the cosmic system. This brings us to the most provocative question of all. Could we someday learn to access or communicate with these other universes? The quantum entanglement experiments that led to this discovery suggest it might be possible. Just as we've learned to manipulate quantum states to create quantum computers, we might eventually develop technology that could detect and perhaps even influence the quantum connections between universes. Imagine being able to peek through the quantum veil to see how slight changes in history played out in parallel worlds, or being able to access the collective knowledge and discoveries of countless civilizations across the multiverse. But with these extraordinary possibilities come equally extraordinary risks and responsibilities. Just as the discovery of nuclear fission led to both power plants and atomic weapons, our growing understanding of the multiverse presents humanity with perhaps its greatest challenge yet. Think of the multiverse as an infinite library, but one where pulling the wrong book could bring down the entire structure. The most immediate concern is the stability of the quantum connections we're detecting. Early experiments suggest that attempting to strengthen these connections, to make them more suitable for communication or observation, could potentially disrupt the delicate balance between universes. It's like trying to widen a small crack in a dam. You might get a better view of what's on the other side, but you risk compromising the entire structure. This has led to intense debate within the scientific community. Some researchers argue for aggressive exploration, suggesting that understanding these connections is crucial for humanity's future. They point to potential benefits like solving our energy crisis by tapping into the quantum energy flowing between universes, or preventing catastrophic events by learning from parallel worlds where they've already occurred. Imagine being able to prevent a pandemic by observing how it played out in other universes, or solving climate change by understanding how parallel Earths handled similar challenges. But others urge extreme caution, warning that we're dealing with forces far beyond our current comprehension. They raise unsettling questions. What if strengthening these quantum connections destabilizes the natural barriers between universes? Could we inadvertently trigger a cosmic immune response from the larger multiverse system, much like how a body fights off foreign cells? Or worse, could we attract the attention of more advanced civilizations in other universes who might not have our best interests at heart? The philosophical implications are equally challenging. If we confirm that every possible version of reality exists somewhere in the multiverse, what does that mean for human free will and responsibility? Would knowing that all possible choices are being made somewhere make our own choices feel less meaningful or more? And how would society change if we could prove that somewhere everyone's deepest what-if questions had different answers? The economic implications are already beginning to emerge. Major tech companies are racing to develop what they call quantum sensing technology, devices that could potentially detect and measure quantum connections to other universes. The potential applications range from predicting market trends by observing parallel economies to developing new materials by studying their properties across multiple universes. But this raises concerns about inequality. Would access to multiverse information become another dividing line between the wealthy and the poor. Perhaps most profound are the implications for human psychology and culture. Throughout history, discoveries that expanded our cosmic perspective, from Copernicus showing we weren't the center of the universe to the Hubble telescope revealing billions of galaxies, have fundamentally changed how we see ourselves. But the multiverse theory goes further, suggesting that everything that can happen does happen somewhere. This could either lead to a new age of human unity, as we realize we're all part of something vastly larger than ourselves, or to a crisis of meaning as people struggle to accept their place in an infinite cosmic tapestry. As we stand at this cosmic crossroads, peering into the infinite possibilities that lie beyond our universe, we find ourselves facing the same emotions our ancestors felt when they first looked up at the stars and wondered what lay beyond. The discovery of the multiverse doesn't diminish our place in existence. It enriches it. Every choice we make, every path we take, becomes part of the grand cosmic dance of reality itself. The next few decades will be crucial as we learn to navigate this new understanding of reality. Will we use our knowledge of the multiverse to solve humanity's greatest challenges? Or will we let our fears hold us back from exploring these new frontiers? The answer lies not just in our scientific capabilities, but in our wisdom, our courage, and our ability to come together as a species to face the unknown. Remember that snow globe we imagined at the beginning of our journey? Now, we know that it's not just one snow globe, but an infinite collection of them, each containing its own universe of possibilities. And while we may be tiny specks in this vast cosmic dance, we are also the universe becoming aware of itself, not just in one reality, but across the infinite canvas of the multiverse. So the next time you look up at the night sky, remember, you're not just seeing the stars in our universe, but catching a glimpse of the greatest mystery of all, the infinite dance of reality itself. And somewhere out there, across the quantum veil, another version of you might be looking up at their night sky, wondering the exact same thing. What secrets will we uncover as we continue to explore the multiverse? What roles will you play in this next great chapter of human discovery? The journey has just begun, and the greatest mysteries of existence are waiting to be unveiled.